In this video, I'm going to be machine checkering a 1911 pistol frame, 20 lines per inch. The first step is to put your rotary table on your mill table and square it up. Once you've squared it up to your table, the next step will be to coax, indicate, and find the exact center of your rotary table. This one here is an 8-inch rotary table. After you've centered your rotary table, be sure you lock down the bolts that hold the rotary table to your mill table. The next step is to use a coax indicator and find the exact center of your rotary table. I usually run about 200 RPM, and I'm going to run my Y-axis and X-axis until I get this needle to stop moving. Once I find zero movement, then I know I'm centered. And there we have almost no movement of our needle, so we're in the dead center. I will zero my digital readout so that I maintain my zero on the center of this rotary table. Okay, now I've got my checkering fixture with the frame set up on the rotary table. Got it clamped down. And this setup took me about 30 minutes, 40 minutes to get the right radius so that I can true up the front strap. The 1911 front straps coming from different manufacturers are rarely perfect. So often you have to true up the face of this in order that your checkering is the correct depth on both sides. You want it to be equal in its depth and cut all the way around top to bottom. Got a 1/2 inch ball end mill that I'm going to use, spin at about 900 to 1000 RPM, and I'm going to rotate my rotary table with the fixture and true up this front strap. Okay, we're starting to get about 30-40% of the front strap bearing contact on our cutter. We're going to come in a few more thousandths at a time. Okay, I've gone in about 4 thousandths total, and what you can see so far is the cutter has not removed any metal right there or at the top, and on the other side of the cutter there's a couple high spots and low spots as well. So we're going to continue to move in a thousandths or two at a time until the entire surface of the front strap is cleaned and trued up. Then I'll come down probably a few thousandths, maybe 3 or 4, and get a nice high cut right down through here that's also equal all the way around. Okay, I've got the checkering cutter in place. It's a 1/2 inch diameter cutter with a long shaft carbide. It's got 5 flutes around at 60 degrees with no flap. The shank starts at a 1/2 inch, tapers down, and then comes back out to a 1/2 inch. I move into a depth of about 34 thousandths to a spacing that I've got measured that will give me 20 lines per inch. I'm going to cut a row of horizontals here so you can see how it's done. I'm moving the table this direction so the cutter is not inside the material. Then I'm going to bring the knee of the table up so the whole mill table will come up in this direction. And then I'll cut my next pass. This is a Caspian frame for a full-size 5-inch 45 ACP build. Okay, the next step will be to take the rotary table and stand it up 90 degrees so that we can cut our vertical lines. Okay, I've got the rotary table and the frame running horizontal, which is doing my vertical lines, and I'm coming in the same depth that I was going before, which is 33 to 34 thousandths. The spacing between each of these checkering for 20 lines per inch is approximately 7 degrees and 3 seconds. That's what I've got on my rotary table. It may vary from setup to setup, also depending on the cutter and the grind that you have. You just have to measure on some bar stocks and sample first before you actually do a frame. Okay, we've backed the cutter out. Now I'm going to rotate the rotary table 7 degrees and 3 seconds, which will give me the next row. Okay, one final note after I finish checkering. Before I remove my rotary table and fixture, or even move my cutter, I double check that I've got the perfect start and stop points all the way around so that I can always correct it if I need it. From the center I went 8 rows this direction, and then from the center I went 8 rows in the opposite direction. It gave me 20 lines per inch using this particular cutter at a depth of 34 thousandths. On my rotary table I rotated 7 degrees plus 3 seconds.